Okay, so we are now on 2B.1, um, part part A still, and this is example number 5. So on example number 5, we have this table here, and it gives us the wavelength x in meters and the wave speed y in meters per second. Okay, explain why a quadratic function would be expected to fit the data well. Well, first we can look at it by analyzing the numbers and how the numbers are changing. So they're growing a little faster than just adding a constant amount. But the other thing we're going to do is, the main thing we're going to do is look at our um, points and analyze them from there. So let me turn on Sylvie. I'm going to reset her. Second plus 712. I'm going to put in the data points. So I'm going to go to stat, edit, and I'm putting in 3, 5, 7, 8, 10. And I'm going to put in 5 and 8/10, 16 and 2/10, 31, 40 and a 4, and 65.7. All right, so I have my data points in. I'm going to go to y equals and turn on the plot 1 so that I can see those data points. Remember, in order to see on the graph, zoom 9. So when I look at these points, it looks like there's a little curvature to it. So I can see that there is a curve to the graph. And because of that little curve, we're going to say that it's concaved up. So we can see that our scatter plot is increasing and it's concaved up. So it's increasing, increasing. Oh, my pen is writing horrible. Increasing and concave. How do you spell concave? Increasing. I'm sorry. My pen is glitching and concaved up. Okay. From the scatter plot. And what that means that it's concave up is that our end behavior is as x. So we can analyze the end behavior. So as x goes to positive infinity, that means y is going towards positive. So we're going to find the quadratic regression model. I'm going to click. I'm going to go to stat, calc, and we're looking for the quad. So we're going to go to 5 for quadratic. And we're going to hit enter. But before we hit enter, we're going to store. So vars, y bars, function, y1. That's telling it that we wanted to save it in the calculator for us. We're going to practice rounding to the nearest 3 decimal places. If you wanted to do it beforehand, go to mode, float, 3. And then now when I run that stat calc for the quadratic and I store it, everything will be rounded. And it's going to calculate and I'll say, okay, bam, here you go. So then it's going to give me my quadratic regression model. So my quadratic regression model, remember this is your A, your B, your C, and we're just going to write that down. So we have y equals 0.747 x squared plus, minus, it was a negative, right? Minus 1.231 x plus 3.0. Okay, so now we have our quadratic regression model. And then we're going to find the R squared. To find the R squared, that's where we have to turn our stats diagnostics on. So we're going to turn on stat stuff. So we're going to make sure we turn on stats diagnostics. To do that, we're going to go to mode and scroll down. So let me grab my calculator back. We're going to go to mode. I'm going to scroll down where it says stat diagnostics. And now I'm going to run it again. Stat, calc, 5, enter. And it's going to give me my R squared. And my R squared is basically 1 at this point because I rounded. And it says R squared equals 1.000. Okay. Now notice because I'm in that 3, that's why these numbers are saying 1 and perfect zeros and all of that. And that's why it looks that way. Okay. Now we're going to turn on the residual plot and analyze the residual plot. To turn on our residual plot, let me grab my calculator. We're going to go to second stat plot. We're going to turn on plot 2. And we want the residual. So I'm going to enter, go down to Y list, second stat, and I'm going to turn on the residual. Okay. Again, I'm going to redo the zoom stat so that when I go look, so you can see how my equation goes through the points. You can see how the points are closely aligned to the x-axis, meaning that there's very little error that's being taken place. And I would just basically explain in words that this is why this quadratic is a good model for the data I have. All right.